Okay, in this video, we are going to simplify rational expressions and we're going to solve these two problems. But before we solve them, it's important to kind of have a procedure. So these are my 4 steps. Step 1 says identify the restrictions on x, and this could mean we can't divide by 0. So that's a restriction. Step 2 says factor the numerator and denominator. Step 3 says divide out common factors or cancel it out. And then step 4 says state the restrictions. So let's begin. So our first step is to identify the restrictions. So in order to do that, we need to factor both the numerator and the denominator and just kind of clean it up a little bit. So instead of saying x squared minus 5x minus 14, we can say parentheses, 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 x, x. And we think to ourselves, what two numbers multiply to give us negative 14? But add to give us negative 5. And we know negative 7 plus 2 could work because 2 times negative 7 is negative 14. 2 minus 7 is negative 5. And then we're going to do the denominator. So x parentheses, x parentheses. What two numbers multiply to give you negative 4? And it sums up to be 0. Well, positive 2 and negative 2. Because negative 2 times 2 will give us negative 4, and negative 2 plus 2 is 0. Now, if factoring is difficult, I'm going to put a playlist on different factoring method. Here, I just did it mentally. So once we factor, it's a good idea to identify the restrictions on x. And for this problem, we can't divide by 0. So one of our restrictions will be x does not equal to 2 and negative 2. Now, step 2 says factor the numerator and denominator. We already did that, so that's done. And step 3 says divide out common factors. So x plus 2 can cancel with this x plus 2. And so our final answer would be x minus 7, this numerator, divided by x minus 2. And then we had to state the restriction, where x does not equal 2 or negative 2, because we can't divide by 0. So even in this case, you have a 2, then you'd be dividing by 0. You can't do that. And with the case of negative 2, well, if you put it back into the original equation, negative 2 squared gives you 4. 4 minus 4 is 0. So you'd still be dividing by 0. So that would be our restriction. And so this right here is our final answer. Okay, this will be our second problem. So again, we want to identify the restrictions on x. Then we want to factor the numerator and denominator. But realizing these two problems, in reality, I went ahead and factored the numerator and denominator first, then we came up with the restriction. So maybe we should switch those two orders. Okay, this is our next problem. We are going to go ahead and factor the numerator and denominator first. So let's do that. X parentheses, parentheses, x. What two numbers multiply to give us 7, but add to give us 8? Well, 7 times 1 gives us 7, and 7 plus 1 gives us 8. Then we're going to do the denominator, same idea, x parentheses, because x times x is x squared. That's why we have to do it like that, as a quick refresher. So we want to multiply to give us negative 2, and it adds to give us negative 1. And we can do negative 2 plus 1, because negative 2 times 1 is negative 2, and negative 2 plus 1 is negative 1. At this point, we can state the restriction because we can't divide by 0. So this piece and this piece will be our restriction, where we want to make these two pieces 0. So x cannot equal, if x is negative 1, we get a 0 here. Negative 1 plus 1 is 0. So x cannot be negative 1, and x cannot be positive 2 because 2 minus 2 is 0. So that's our restriction. And then step 3 says divide out common factors. So we have an x plus 1. Here we have an x plus 1, so we can cancel them. And so our final answer will be this piece divided by this piece and this restriction. So x plus 7 divided by x minus 2, where x does not equal negative 1 and 2. Because at negative 1, if you put a negative 1 here and back into the original equation, you'd be dividing by 0. And if you put 2 back into the original equation, you would also be dividing by 0. And so this right here is our final answer. And that's all we need to do to simplify rational expressions.